hello, good morning. Well, at least it's morning for me at this point. Oh my gosh, hold on. Oh, kind of just got up, had some waffles, and said, time to study. So welcome back. This is hopefully the last video I'm going to do for GDScript from zero. The free course that the Godot documentation has. The last video or the video before, I tried to leave a link of this free course. However, because my YouTube channel is still like not really confirmed to be a YouTube channel or is possibly a bot to YouTube, I can't put any external links in my description. So hopefully as time goes on, I can start actually putting and providing links, which is weird because I think I put links for the music I did, or not I did, I'm so sorry. The music I used in the animation video. So that was really weird that maybe because it was YouTube videos I was linking and not like, oh, external. Right. So right. Anyways, I pretty much just got up, and I really am looking forward to finishing this here. Feel free again to use this as a study aid, a sleep aid, or follow along. For today's music, there is a really cool playlist, relaxing Animal Crossing City Folk music to study, chill, relax to by Tipsy. So shout out to Tipsy for this. I love Animal Crossing music, and I love this character, Bunny. She's amazing. But yeah, so I'm gonna go ahead and use some Animal Crossing to get me through the rest of this. We're at the home stretch. So lesson 19, looping over arrays. We use the range function in combination with for loops. Func run for number in range 3, yes. The range function produced an array that the for keyword could loop over. We can give for loops any array and they will loop over them just the same. Instead of using the range function, we could manually write the numbers and get the same result. Right. So you could like make a variable that that is an array that holds these, so you don't have to manually put it in. You could say for number in list, and the list variable holds these, so it doesn't, in case like let's say you had 100 numbers, you don't have to write them all out in this for statement. For each element inside the array, the for loop extracts it, stores it in the temporary variable named number, and executes the loop's code once. Inside the loop, you can access the number variable, which changes on each iteration. The code works regardless of the array or where you store it. Often you will store arrays and variables for easy access. Yep, like I said. What will this code print? Var numbers for numbers print number. 0, 1, and 2. Yeah. Making the turtle walk with a loop. In the previous lesson, you made a turtle walk along a path by writing vector2 coordinates in an array. It's a for loop that makes the turtle walk along the path. The loop works like this. For each coordinate in the array, it moves the turtle once to that cell. For cell in path, turtle.move to cell. Okay, so we have the move function that takes in the parameter of path. So the path is most likely an array that has the coordinates. So for cell, so each value in the array path, turtle.move to cell. Yep. It's the same principle with unit selection, like these. For each coordinate in an array named selected units, we check if there is a unit in that cell. If so, we select it. In that case, we could use an array, a loop, and a condition together. This takes a really long time because let's say this grid was like 50 by 50. It would have to go through each one, right? And that's like a long ass time. So there's also quick lookup times. Like it goes back into is it notation? O of log n or O of O squared. Oh my gosh. Yeah, I forgot about those things. Well, yeah, I have to refresh my memory on that. O of n is like the best one, right? I believe. But yeah, which I believe a dictionary would do better of like lookup of quick stuff, or there was something you could make. What was it called? A map, something map. Hash map. Yes, a hash map is really good for that. Var units. Okay, so for each coordinate in an array, yes. In that case, you loop through the condition. So variable units is an empty list. Variable selected units equals empty. So select unit cells for cell and cells. If cell in units, selected units dot append cell update. Yeah, there you go. That's kind of, yeah, I believe that's how a hash map works is that you just collect it all first, put it in the array, and you're like, all right, boom, bada bing, bada boom, we are good. Like as you go through, you add a +1. Yeah, I remember that. Okay. The code above uses several features you haven't learned yet. In a condition, the in keyword allows you to check if a value exists in an array. The array's append function appends a new value at the end of the array. Notice the use of a period after the selected units variable to call the append function. It's because this function exists only on arrays. Dot append, yeah. When functions exist only on a specific value type, you write a dot after the value to call the function on it. We'll revisit those two features again in the following lessons. The beauty of loops is that they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 units to select. It is all accomplished with only a couple lines of code. That's the power of computer programming. In the following practices, you will use arrays combined with for loops to achieve similar results. So we need to move the robot along the path and back to the drawing board. Our AI pathfinding algorithm provided a path for the robot to move to the right edge of the grid. Your task is to use a for loop to make the robot move. To move the robot, call its move_to function, like so, robot.move_to. Okay. And then we want to move the robot, call it move_to robot, dot move_to path. Is that what we're doing? Yeah. Woo. Period. Okay. We want to draw many rectangles, something surprisingly common in games. However, writing this code by hand can get tedious. Instead, you could store the size of your shapes in arrays and use a loop to draw them all in batches. That's what you'll do in this practice. Use a for loop to draw every rectangle in the rectangle sizes array with the draw rectangle function. The rectangles shouldn't overlap or cross each other. To avoid that, you'll need to call the jump function. Remember the jump function? Good times. Of rectangle. And then you want us to jump. And then jump, but like where? Because we need coordinates, right? My bad. Okay, so let's make sure they don't overlap by having it go by 400. There you go. Alright. Cool. Strings. Throughout this course, we've mostly stored numbers and variables, but what if we wanted to store a player's name? This is where strings help us. Strings are instrumental, get it? Instrumental, in games and applications. We use them to display information such as the description of a spell or the name of a character. Robot. What are the strings? What are strings? A string is a value type which holds text. To create a string, you write text wrapped in quotation marks. For example, this is a text string. The quotation marks differentiate strings from other value types and function names. You may remember we've used strings before in previous lessons. Yes, we did. My name, print my name. Under the hood, strings are arrays of characters. Yes, they are. In fact, because you could say yes, and then each character is, yep, in fact, we can use a for loop to loop through the characters of a string as we would with any other array. Which of these are strings? You guys are. Yep. Why we use strings? Every piece of text you see in this app is a string that Godot is displaying for us. Much like how vector2 variables make calculations easier, string variables come with many helper functions and tricks we can use. We can use arrays to store strings too. This is a useful chaining for chaining animations. In this example, the play animation plays a specific animation. Variable combo equals jump, damage, jump, level. Func perform combo. For action and combo, play animation. Oh, you can assign an animation to a string. That's cool. In the next few practices, we'll use strings in combination with different concepts from earlier lessons. Practices, creating string variables and using an array of strings to play a combo. Okay. Currently, the robot has a number stored in the robot name variable. Okay. Change the robot name variable so that it's a string instead. You can give it any name you'd like. Dawn Soap. That's my game tag. Gamer tag. Dawn Dish Soap. But not dish soap, I just say Dawn Soap because I'm not sponsored. But you know, it's cool. Like I just totally ripped off their name. Of course I'm not sponsored. Using an array of strings to play combo. In this practice, we'll chain together animations using an array of strings. You might find such combinations in fighting games. The robot has the following animation names. Jab, uppercut. Populate the combo array with animation names as strings. Then, for each action in the array, call the play animation function to play them. The array should contain 3 values, so the robot makes these 3 attacks. 2 jabs followed by 1 uppercut. Alright, so jab, uvu java. For hit in combo. There you go. Oh, sorry. I gotta like sneeze, but like, it's gone now. It left me. Functions that return a value. Until now, return! Yes! Okay, until now you learned that functions are sequences of instructions you give a name and you can call anytime. On top of that, functions can make calculations and return new values. Let's look at some examples to see why it's useful. Built-in functions that return a value. Many functions built into GDScript make calculations and return a new value. For example, the round function takes a decimal number as an argument and gives you back a new number rounded to the nearest digit. Variable number equals round 3.4, print number. 3. Yes. Imagine you have a game where you track the player's health as a percentage, a decimal going from 0.0 to 100.0. When displaying the health on the interface, you don't want to show it the decimal part. In that case, you may use the round function like so. Variable rounded health, round health, set text, yes. Notice how we assign the result of the function call to a variable. Because the round function returns a new value, we need to either store the result or use the value immediately. Above, we assigned it to a variable, but you could also do the following. Set text round health. Okay. Yeah. Okay. You can assign, look at this turtle. You can assign the return value of a function call if you plan on using it more than once. A cooler example, lerp. Interesting. Lerp, huh? The lerp function, short for linear interpolate? Linear interpolate? Hold on, now I'm curious. Oh, why is it in light mode?
Interpolate.
Interpolate, okay, thanks. Appreciate you. Oh, it takes 3 arguments, the 2 values to average, and a value between 0.1 and 1.0 to skew the result. It takes 3 arguments, okay. There we go. Whoa, sorry, turtle. Okay, so the lerp function, short for linear interpolate, calculates and returns a weighted average between 2 values. It takes 3 arguments, the 2 values to average, and a value between 0.0 and 1.0 to skew the result. In game programming, it's used to animate things moving towards a target with a single line of code. Func_process delta, remember _process delta is going through the frame, the game's framework, kind of like frames per second, but technically it's like every computer has a different _process delta, so it accommodates for your computer instead of being a set fixed like frame by second type deal. Frames per second, yeah. Okay, gotta remember that. So we're taking that, my computer's frame rate, and we're saying the position variable, or the position is equal to lerp, which is taking 3 arguments, the two values we're dealing with, which is the oh, you can create a variable and then use said variable in the thing. Interesting. How does that work? Is that okay? So you're taking said position, get local mouse position, and then you're saying the number between 0.0 and 1.0. So 2 times delta, which is our frames, whichever our frames are working with, times 2. Interesting. Get local mouse position. Woo, ha, 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 ha. Sorry. I'm still a little lost on this part, because how can you assign the variable and then use said assigned variable and then say this is the variable value? Okay. Alright, maybe they'll explain it. Every frame, the code calculates a position somewhere between the turtle and the mouse cursor. The lerp function takes care of everything. It's not the most robust approach for smooth movement, as you'll learn in the future, but it's a helpful function nonetheless. Okay, so every frame the code calculates a position somewhere between the turtle and the mouse cursor. And that's what this does. Okay, that's what lerp is taking care of. Writing a function that returns a value. You can make your functions return values. To make a function return a value, you use the return keyword followed by the value in question. In previous lessons, we had characters walking on grids, and for those practices, you were working directly with cell coordinates. Well, cell coordinates don't respond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell's coordinates to a position on the screen in pixels. Cell coordinates don't correspond to positions on the screen. Like vector 2, 0.1, like, okay, so those don't. To find the center of any cell on the screen, we need to convert the cell's coordinates, the vector 2, to a position on the screen in pixels. Okay. Cell world position 60, 60, 180, 60, 360. Okay. I'm picking up what you're putting down. So we can't use these, we have to use this by pixels. Because in the game, you are working with pixels. Like if I wanted a 2D pixel game, you know, when you're making like a tile sheet, you have to it's all in pixels, so that it can all align properly. Makes sense. So same for vectors. They're not pixels, so you have to convert it to pixels. To do so, we use a, I'm sorry. It is actually quite early. I got up pretty early for this. To do so, we use a function. The function does 2 things. First, it multiplies the cell coordinates by the cell size, which gives us the position of the cell's top left corner on the screen in pixels. Then, we add half of the cell size to get the center of the cell. The function returns the result, allowing us to store it in a variable. Okay, another math thing. Okay, I wish I kind of do. I could use Clip Studio. So we use a function. First, it multiplies the cell coordinates by the cell size. So, 2. Oh god, I don't have my stylus. I'm using a mouse. X, Y, right? Multiplies the cell coordinates by the cell size times cell size. Okay. So let's say X is 2 and Y is 4. Or, no, I don't know. Let's say, well, it says 120 here. Okay. Plus cell size divided by 2. So then we add half of the cell size to get the center of the cell, plus cell size over 2. I guess it would be prettier if I just like did that to where's my phone? Oh, right here. I'm just gonna use my phone as a calculator. Just so I can just manually do it myself. So we're multiplying the cell size. If we say the cell size is so this function is going to run it for you. Convert to world coordinate cell using the cell. So cell, which is, oh wait, hold on. Now I'm getting it wrong. Oh my gosh, hold on. So you're saying first it multiplies the cell coordinates by the cell size, which gives us the position of the cell's top left corner of the screen. Then we add half of the cell size. See? So you're saying cell size is the coordinates 120, 120. Oh no. This is saying how big it is. And then we're gonna find cell by saying cell times. But when you find cell, we don't know what cell is yet. That's the thing. Unless you input it yourself. Like you want 5 cells, so 5 times cell size. So that's 600 by 600. 600 plus cell size. Because when you multiply, because like you can't, I'm pretty sure you can't multiply a vector to an integer. So I'm a little confused how that works. The return keyword, because cell size, yeah, 120, 120. Variable world position equals convert to world coordinates vector 2, 1, 1. Okay, so the cell is 1, 1. And you're going to multiply it by 120, 120. So each one has something that, okay. And then you take the 120 divided by 2, which is 60. And so you add that to the 120 you got, so it's 180, 180. Okay. So the cell will be a coordinate. It will be a vector 2 coordinate. And then the cell size is what we want, right? So to do this, so we use a function. The function does 2 things. First, it multiplies the cell coordinates by the cell size, which gives us the position of the cell's top left corner on the screen in pixels. Then we add half of the cell size to get the center of the cell. The function returns the result. Sorry, my brain is really hard. It really struggles with math and stuff. So I have to take an extra long time to just make sure I'm understanding what exactly is happening. For some, this might be super simple, like, oh yeah, of course. For me, it's not that obvious. So I have to really make sure I'm picking up what they're putting down. So this is the center. When we find the world position, this is the center, 180, 180. So the top left corner is 120. So size, which gives us the position of the cell's top left corner on the screen in pixels. The cell size. So if like the position is 0, 0, you times it by the cell size 120, that's 0. And then you divide that by 2, it's 0. You can't divide 0 in... We'll see. Okay. Well, I kind of get it, but then kind of don't. Some functions return values and some do not. During practices, you can learn which functions return a value using the documentation panel. It will display if the practice requires using specific functions or variables. They are functions that start with the term void, do not return a value. Oh, interesting. So it's just like C++, with voids. Any other term means the function does return a value. You'll learn more about what other terms mean in a couple of lessons when we explore value types. Okay. For now, let's practice returning values from functions. Alright, let me see if I can understand. Converting coordinates from the grid to the screen. Define a function that converts a position on a grid to the screen. Okay. The function takes a vector 2 cell coordinate as an argument. It should return the corresponding vector 2 screen coordinates at the center of the cell. So the vector 2 coordinate is what we are used to. A vector 2 screen coordinate is the pixel, which is where we got that little tidbit of information. So we take the cell, so that probably looks really wrong. Oh, yeah. I didn't put a variable screen, or we said world position, so world pause equals cell times cell size plus cell size divided by 2. Return world position. There you go. That's what I just forgot, the variable. Real. Okay. World position. So like what we see. So the computer has its own version of how it views the coordinates, and then we have our own version. So that's what like output is for. The print statements is to see what we know is our language, but the computer is like, this is something completely different because all of these characters have data addresses, and that's what I'm looking at. But like for you guys to understand, I'm gonna put out this print statement, right? So okay. Appending and popping values from arrays. In previous lessons, you learned how to create arrays to store lists of values and how to loop over them. It's nice, but you won't go far with only that. Yeah. The real strength of arrays is that you can add and remove values from them at any time. It allows you to queue or stack data. For now, let's take another example. Tracking orders in a restaurant management game. You're making a restaurant management game where customers place orders and you need to handle them as they come. In this game, customers order meals that end up in a queue. You need to prepare them in the kitchen. In this example, we simulate orders arriving and getting completed over time. Pending orders completed. Tomato soup, toast, burger. Oh god, okay. How do you keep track of pending and completed orders? With an array. When a customer purchases a meal, you want to append it to the array. Then, as you complete a meal in the kitchen and serve it, you want to remove it from the array. You can do that with the append and the pop front functions of the array, respectively. Try to read the code below before moving on. Don't worry if not everything makes sense, as we'll break it down. So we have variable waiting orders is an empty list. Variable completed orders is empty list. We have a function called add order with the parameter meal name. Waiting orders dot append meal name. So add order is adding the meal name to the waiting order. Then you have the function complete current order, which has a variable called first order equals waiting orders dot pop front. So it seems you can't, when doing this, you have to work from the queue. Whoever's first come, first serve. There you go. That's the order of this. So first order equals waiting orders dot pop front, which means it's no longer a waiting order in the waiting orders array, and now it has been put onto the completed orders array because you finished it. And so next in line, when you pop the front, the next order, so like what we saw was tomato soup and then burger and then salad. When you pop front, the tomato soup goes away, but then burger takes its place. So that way it becomes the first order because it is now the first one. First come, first serve. Notice how we call some functions by writing a dot after a variable name. Like a given value type can have subvariables, it can also have its own functions. Functions like append and popFront only exist on arrays. That's why to call them, we need to access it from the array using the .array.append. Let's break down the code. We queue orders and awaiting orders. Right. Okay, I basically just kind of explained what this does, right? Right. To represent libcs in the code, it means we're completing the function's code. We use that to break down code examples and make them easier to learn. Yeah. Okay, I basically just explained what all did, so. Using arrays as stacks. Another common use of arrays is stacks of data. Take a factory management game where you need to retrieve materials from stacks of crates. They arrive at the factory pile up vertically, and you need to take them from top to bottom. Variable crates equals gems, healing heart, shield, func. Use top crate, variable crate equals crates.pop back. Use crate. Interesting. Top to bottom. So, oh, pop back means, okay, so this was first, second, and then that's like from the back to the front. I see. Gotcha. To take a crate from the back of the array, this time we use the pop back array function. This function removes pops the last value from the array and returns it to you. Here we pop the last value of the array and print what's left of the array to demonstrate how the array gets smaller. Crates.popback. Sword and shield. Oh, it took out gems. I'm sorry. That took me a minute just to... Like popFront, the function returns the value removed from the array. You will often store that value in a variable. The value in question could be the crate's content, which you can then use to give resources to the player. In the following practices, you will use the append, popFront, and popback array functions. So completing orders and clearing up crates. The waiting orders array will be filled over time. Your job is to move orders from the waiting list to the completed orders list using the array's append and popFront functions. Remember that the array's popFront function returns the popped value, which allows you to store it in a variable and then pass it to another function. Okay. Which allows you to pass it to another function. Right. Your job is to move orders from the waiting list to the completed orders list using the arrays pen and pop. Okay. First order equals waiting orders dot pop front and then completed orders dot append first order. Oh, I forgot variables. We need variables. Okay, I gotta get better at that. Crates are piling up on the platform. Move them out of the way by popping them from the crates array. Okay. Right. You need to remove them from top to bottom using the array's popback function. Your code should remove all the crates in the array using a while loop. Careful, if you run a while loop carelessly, you can lock the software. Yeah, I was gonna say while crates dot size, but I don't think you can use that here. So yeah, while crates is true, you're gonna take variable item or top item equals crates dot pop back, and then you're going to return crates. Or, well, you don't need to keep it in a variable. You just pop it. That's all they're asking. Yeah, never mind. You just keep popping it until it does it. Yeah, my bad. I was doing too much again. Yay! These are a lot longer lessons than the last time, because I'm on 23 and it's already 46 minutes. I'm like, dang. Which means we're getting more complex, or I'm just going slower. Probably both. Accessing values in arrays. You learn to loop over all the values in an array using the for keyword. For value in array, print value. Yeah. Oh, sorry. Ooh. What is this? Oh, the sun's finally coming up. It's been raining all week, so it's nice to have a little sunlight. But what if you need to access the third item in the player's inventory, the 10th item? There's a dedicated notation to, yes, the index, period. Access one element in an array by index. To do so, you use the square brackets with a number inside the brackets. Index 0 is the first element in the array. Yes, you're right. Index 1 is the second element in the array, and so on. You would access the fourth element in the array in the inventory like so. Yeah. How would you access the third item in the inventory array? The third? This one. What if you want to access the last or second before last item in yes, you do negative indices. Period, queen. That's very convenient when you need to quickly access elements. How would you access the third to last element in the array? The third to last. -1 is the last. -2. -3. Yeah, because you're not starting with you're starting with 0 when going positive, but you're not starting with 0 when going negative. So you can't access non-existent indices. Yes. So that's what I meant when I was saying like, oh, while such and such is greater than such and such. Sometimes when you're looping through a variable thing, or an array, it'll try to find whatever's to the right of it, but you're already at the end of the array. So you have to make sure you make a conditional that stops it at the end of the array. If you try to access an index that does not exist, you'll get an error. You have to be careful always to access existing elements in the array. There are a couple of ways you can check for valid indices. One of them is checking the array size. Dot size! That's what I want to do. Arrays come with a member function named size. You can call it, and then you have to do size -1 to account for 0. Yeah. So there's 4, but remember it goes 0, 1, 2, 3. Yeah. Oh, it makes me happy remembering this stuff. The maximum index you can access is an array is array.size -1. It's the last item in the array. Yes. Inventory.size -1. Use item. Inventory last item. Index, yeah. In the following practices, you'll use array indices to realign train tracks. Oh my gosh. I cannot stop yawning. Trying to drink water too, instead of like Dr. Pepper at 9:30 a.m. I'm trying to be healthy, guys. I'm trying. You use array indices to realign train tracks and grab the correct item in inventory, using the right items and realigning the train tracks. Okay. Using the right items. In our game, the player has an inventory that works as an array under the hood. Okay. They want to equip a sword and a shield to buff their characters. Like before, we need you to find them in the array. You need to access elements in the inventory array by index to do so. Call the useItem function with the item as an argument to use an item. For example, you can use the first item by calling useItem inventory 0. So you need to access elements in an array by index to do so. What do you want me to do? Call the useItem function with the item as an argument to use an item. Correct items have been picked. Pick correct item out. We want to find a sword and shield. And then if you do it again, Yeah, 3, but okay. Because I'm like, it's empty, so I'm like, how do we? But I guess it's all they said under the hood, so cool. We have train tracks broken down into little chunks in our game. We use them to make modular tracks and draw circuits of all shapes and sizes. However, several chunks are misaligned. You need to find them in the tracks array and pass them to the align function. To do so, you need to access the array by index. This time, though, you need to access them with negative indices. Right. Oh god. Well, how many are there? I guess it doesn't matter, because you could just do negative 1, 2, 3, 4. Align. How many does align take in? Does it only take in 1? I thought so. Yeah. Because how to, like, if, like, an array has, like, an array within an array, you would go, like, in the first array, 1, in item of that array, 0. Like, 1, 0, you know? But that's, we're going ahead, getting ahead of ourselves. Creating dictionaries. Oh my gosh, dictionaries! The key and value pairs. In the last lesson, we used an array to represent a player's inventory. With just an array of item names, though, we can't easily keep track of the amount of each item. Instead, we can bundle the item names and amounts into a single dictionary. A dictionary is a data structure that allows you to map pairs of values. In the pair, we call the first value a key, as we use it to access the second. In other words, a dictionary has a list of keys, and each key points to a value. To define a dictionary, we use curly brackets. A colon separates each key and its value. A comma separates each key and value pair. Dictionaries can hold any values. Dictionaries can map about any value to any other value. For example, we can use the name of an item as a key, and the amount as the corresponding value. This makes dictionaries excellent for keeping track of a player's inventory. Here we match the name, a string, to the amount, a number, but a key could be a string, a number, or even a vector. Okay, but like, who wants a dictionary where you have like a string key, then right after that an integer key, and then after that a vector key? That's kind of crazy. We could get the following error. Although we can have all these different keys, keep in mind that every key has to be unique. That means we couldn't have a dictionary like the following. Yeah. In the above example, which key would cause an error? Healing heart. Accessing values. We access the value of keys by writing the dictionary name with the key in between square brackets. Yeah. Yes. How would you access how many gems the player has? Inventory gems. Changing values. We can also change the values directly, which is useful in our case for adding or removing items from the player's inventory. Inventory healing heart plus equals 1. Yeah. Because you're accessing the value. Inventory. Yeah. I want 12. Thanks. In the following practices, we'll use a dictionary to create a player inventory and create a function to change the value items. Creating an inventory using a dictionary, increasing item counts. Cool. So let's give some items to the player. We use a dictionary for the player's inventory. We define the inventory variable for you, but it contains no items yet. Give the player the following items by adding the correct keys and values to the dictionary. 3 healing heart, 9 gems, 1 sword. Yes, so healing heart. Period. Alright. Increasing item counts. We want to change the item counts in the player's inventory whenever the player picks up or uses an item. We've started the add item function for you. The inventory dictionary should use the item name parameter, okay, as the key to access its values, and we should increase the value by amount. To test this practice, we'll use your add item to function to increase the item count of healing heart, gems, and sword. So we're just saying inventory dictionary should use the item name parameter as the key to access its values. So we're saying item name plus equals amount. Oh wait, just kidding. The item name parameter as the key to access its ha 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 ha. Yeah. Plus equals amount. Yeah. Perfect. Thank you. Looping over. Oh God. Okay. Looping over dictionaries. Like with arrays, you can loop over dictionaries. You can loop over both their keys and values. Let's see how it works with two examples. Displaying an inventory's content. To display the player's inventory, you need to know what it contains. You need the name and amount of each object. And from code, you can only achieve that by looping over the whole dictionary and processing key value pairs one by one. To get the list of keys in a dictionary, you can call its keys member function. Oh, that's right, keys and then dot keys dot values. And I think the one for both, I forgot what it was called, but we'll go over it. Var inventory, yes, for item name in inventory.keys, print the name. But it's something we do so much that you don't need to call the function. Instead, you can directly type the variable name in a for loop after the in keyword. The language understands that you implicitly want to loop over the dictionary's keys. For item name in inventory, print item name. You can get the values with the syntax dictionary key as you learned in the previous lesson. We can loop over the inventory keys, get the corresponding values, and display all that information in the user interface. For item name and inventory, variable item count equals inventory item name, print item name plus colon plus string item count. I see what we're doing. Concatenate. I think it's called concatenating. Instead of printing the key value pairs to the output console, we can code and call a dedicated function that displays items in the user interface. Func for item name and inventory, variable item name equals inventory item name, add item, item name, item count. Interesting. So add item, dedicated function that displays items. Okay, add item. Mapping grid cells to units. We can also use a dictionary to map units to their position on a game board. That's how you typically code a board game in a grid-based RPG or a tactical RPG. While we focus on string keys so far, GDScript dictionaries accept any value type as a key, allowing you to map everything to anything. The only limitation is that every key must be unique. So vector, so in this position, this key position, we have a robot, this key position, a turtle. Using a for loop, you can use the key value pairs to place units on the board at the start of the game. For cell in unit cells, variable unit equals unit cells cell. Right. Add unit cell. So the unit, so for cell in unit cells, like a vector, the variable unit holds unit cells cell, like value. Oh, for each key in this list, where the unit is going to be the value, and so we're going to put the value, add the unit of the value, which is robot, in the cell that it belongs to. Got it. In the following practices, you will loop over dictionaries and process their content, displaying the inventory, placing units on the board. We use a dictionary to represent the player's inventory in this game. The dictionary keys are the name of items, and they map to the number of items that the player owns. You need to loop over the dictionary and display the name and amount of every item in the inventory. I think I just read that, but I didn't read it at the same time. Okay, I'm sorry. I didn't mean to, like, outburst. I'm just trying to, like, wake up. Oh no, here comes the audio. You need to loop over the dictionary and display the name and amount of every item in the inventory. To do so, call the display item function. It takes two arguments, the item name and the amount. Oh, hold on. For item in inventory. Right, display item, and then inventory item. Oh, my bad. Colon. Yay. We have a dictionary named units that maps a cell position on the grid to a unit to put there. We have a dictionary named units. Okay. That maps a cell position on the grid to a unit to put there. Using a for loop and the place unit function, place every unit in the unit's dictionary at the desired position on the game board. For unit and units, place every unit in the unit's dictionary at the desired position on the game board. So for each key, when we're going over in vector 2, we want to place unit, which is units unit. Expected 2 arguments. Okay. You didn't say that in here, but I digress. Okay. Value types. In your code, values have a particular type. You have already learned about several: whole numbers, decimal numbers, strings, 2D vectors, arrays, and dictionaries. The computer uses the type of a value to know which operations and functions you can use with them. As a result, it's essential to understand types. They are not fully compatible with one another, and misusing them will cause errors. A prime example: you want to display the player's health in the interface. Your code tracks health as a whole number and a value of type int, short for integer. Var health equals 100. However, to display it on the player's screen, the computer wants text. It needs a value of type string. You can concatenate 2 strings with the operator. Print hello plus there. Hello there. So the following code looks like it could work at first glance. Health plus health. But when running the code, we can get this strange error. I think you have to do like str bracket health or s. Yes, not bracket, but it's parentheses. Yeah, that's what you can do. It tells you can't add values. They're incompatible. In that case, you need to convert the health number into a string. You can use converting values into strings. You can get the text representation of value by calling the str function. And then that way it will actually run 100. In this case, it turns the number into 100 into string 100, or whatever number health is currently. Converting strings into numbers. Use int or float. Yes! You can also convert strings into whole numbers or decimal numbers using respectively the int and float functions. Those functions can convert what the player writes in a text field into a number. For example, the number of potions to sell at once in a shop. I like potionomics. Variable player input equals 10. Variable as whole number equals int player input. Some types are partially compatible. Most types are incompatible. For example, you can't directly add or multiply an array with a number. However, some types are partially compatible. For example, you can multiply or divide a vector by a number. You didn't let me do that before. You said a vector isn't, you can't do that with an int. But whatever. I guess it's subject to case. I don't know. Vector 211 times 10. So it just does the little like PEMDAS moment. Rainbow multiplication. It is possible because other developers define that operation for you under the hood. Thank you, devs. Appreciate y'all. However, you cannot directly add or subtract a number to oh, okay, that's what it was. You'll get an error. That's why in earlier lessons you had to access the subvariables of position to add numbers to them. Okay, they literally just answered what I was complaining about. That's funny. A surprising result. Take the following division 3 divided by 2. What result would you expect to get? 1.5? No. It takes the modulo, right? 1. Yeah. Well, for the computer, the result of 3 divided by 2 is 1. Wait, what? That's because for the computer, the division of 2 whole numbers should always result in a whole number. When you divide decimal numbers instead, you will get a decimal number as a result. Modulo, sorry, that's not the same thing. Modulo is the percent sign. And it takes whatever the remainder is from deducting both sides, right? Am I remembering that? Hold on. Why is it not in dark mode? This is weird. I don't like that it's not. It used to be in dark mode. What happened? The modulo operator finds the remainder of a division operation. Remainder of division, yeah. Example 5 mod 3 equals 2. That means that when 5 is divided by 3, the remainder is 2. Yeah. That's what I thought. I need to change that because I'm used to having dark mode and I don't know why it's not in dark mode. Ugh. Yikers. Anyways, sorry. Even if it's a 0, adding a decimal place tells the computer we want 10 decimal numbers. This shows you how mindful you need to be with types. Otherwise, you will get unexpected results. It can get pretty serious. Number errors can lead to bugs like controls not working as intended or charging the wrong price to players. Ooh, that would not be good. Understanding and mastering types is a key skill for developers. Programming beginners often struggle due to the lack of understanding of types. Languages like GDScript hide the types from you by default. As a result, if you don't understand that some are incompatible, you can get stuck when facing type-related errors. You want to keep that in mind in your learning journey. When writing code, you will need to understand everything that's happening. That said, let's practice some type conversations. Type conversions. Displaying the player's health and energy. We want to display the player's energy in the user interface. Currently, our code has a type error. We're trying to display a whole number while the display energy function expects a string. Using the str function, clear the type error and make the energy amount display on the interface. You can't change the energy variable definition. Setting it to 80 would break the rest of the game's code. You must convert the value when calling display energy. You got it, boss. Letting the player type numbers. In our game shop, we want to let the player type numbers to select the number of items they want to buy or sell. We want to know the number of items as int, but the computer reads the player's input as string. Your task is to convert the player's input into numbers for the shop's code to work. Using the int function, convert the player's input into a whole number and store the result in the item count variable. You're trying to convert the player's input into numbers. So reset. So there's supposed to be 0 argument. You can int a function? Really? I mean... Alright. No, that's what I thought. Player input is not of its original type anymore due to the value change. Yeah. Is get player input doing it for us and we're just plugging this in? But it said it expects 0. That's why I'm a little confused. Yeah, it's saying 0. And we don't want to change player input. Are you saying... Sorry, I guess you mean this? So, oh, player input is get player input is actually like when they type in something. So if I type in 9 and then press OK, right? So get player input would return 9 string. Then we do item count equals int player input. That's what that's doing. Yeah. Gotcha. I understand now. Oh my gosh, it's the last lesson. Specifying types with type hints. By default, GDScript is what we call a dynamically typed language. That means that you can just write variables, assign them as a value with a number, and assign them another value with a different type. Unlike in some other languages, in GDScript, the following code is valid. That's insane, which I've said since the very beginning I don't like. But this feature often causes problems down the line. Let's take one example. Cell size, decimal number, or 2D vector. Games use grids all the time, be it for grid-based gameplay or to make algorithms faster. When working with grids, you need to convert grid coordinates into positions in the game world all the time. To do so, you give each cell a size in pixels, which is, if I remember off the top of my head, I'm not looking at the thing, it's the vector 2 coordinates times cell size plus the cell size divided by 2. Yeah. right? You'll likely pick one of the two types for that, float or vector2, because pixel positions on the screen use vector2 coordinates. Either of those two values would be fine. Cell size equals 50.0, cell size equals vector2 50.0, 50.0. Using a vector2 could simplify some calculations. For example, when converting grid coordinates to game world coordinates. Yes, cell... Oh wait, did I get it wrong? Well, no, cell is a vector too, so technically I'm still right. Yeah. Yeah, variable cell size equals 50/50. Grid to world cell. The cell times the cell size plus the cell size divided by 2. In this example, because both cell and cell sizes are vector2 values, we can add them. However, if cell size is a float, we will get a type error. Well, because cell size, you need two. I need an x and an y. It can't just be one, right? Grid to world cell. Oh, but you're trying to say the size. You just want it to be 50 all in all. But you need to be able to have an x and y when operating that. Worse, due to dynamic typing, we won't get an error right away. We only get the error when calling grid to world vector211. Oof! And that's a big problem, indeed. Because we're learning, we only have small code examples in this course, but your game's code will get long and split into many files. When coding, you often forget about the code you wrote several weeks ago. And with a lot of code, it could take hours of play before players trigger a type error in your code. Using type hints. Fortunately, GDScript has optional type hints. Type hints let the computer know the value type you want for variables and report errors before running the code. To specify the type a variable can accept, you can write a colon and a type after the name when defining a new variable. Variable name type. That's so long. You could tell the computer you want cell size only to accept vector2 values like so. So instead of just having int cell size or vector2 cell size, you have to say variable cell size colon vector2 equals vector2 50.0 50.0. That seems tedious, but if it means that I can have specific variables for specific things, I will take it. I will have to learn. If you try to replace a cell size with the value of another type later, the computer will not let you. Period. As it shouldn't. Letting the computer figure it out. GDScript comes with a feature called type inference. In many cases, but not all, the computer can figure out the type of a variable for you. To do so, you write colon equals without the type. The computer will set the type using the value after the equal sign. We could make cell size a variable of type vector2 like so. Oh, interesting. This takes little typing, yet you get the benefits of using type hints, like the computer reporting errors better and faster. So, in many cases, but not all. Yeah, I think I would much rather, if anything, I would stick to doing this regardless. I want it to be as readable as possible, like, for myself mainly. But if other people were seeing it, I want it to be readable. And this does not seem as readable, in my opinion, but that's just me. Why bother to add hints? When you give the language hints like that, it will prevent major type errors. When you work in Godot, you will see that the computer can report issues as you write the code. It makes the benefit even greater. Type hints can also help improve the readability of your code. It can help to put more information directly in the code. As we saw, types are essential when coding, and when using type hints, the computer will add them to the engine's built-in code documentation system. There's an incredible third benefit for you. By using type hints, you will learn types much faster. It's excellent for learning. In the following practices, you will write the correct type hints to make the code error-free. Add the correct type hints to the variable. Our variables get the correct values, but not the right hints. Using your type foo, add the correct type names in the variable definitions. You need to write the type name between the colon and the equal sign. Alright, so that's a vector2. That's a string. Well, oh, is it? Yeah, it's uppercase. Okay. Whole number. Integer? Do I have to type in integer? I forgot. I already forgot. Oh god. Float? Is it int? I'm sorry. I'm already forgetting. Shoot. Hold on. Reset. Oh. Bruh. Okay. Everyone else is capitalized but int. Poor int. Oh. And float. It's just funny because I'm used to str, but you can't use that. You have to call it string. Fix the values to match the type int. Whole number int. Fix the values. Okay, so this is going to be 4. This is going to be hello world. This is going to be... I'm going to do this instead. And that's 3.14, the start of pi. Period. Congratulations! You completed Learn GDScript from zero. You now have the basics you need to make games with the Godot game engine. You can keep learning with the free series Getting Started with Godot. This is an open source project. Like Godot, this app and course is free and open source. You can find the app source code and contribute translations here. That's so cool. Getting started with Godot. So I'm back to the step-by-step. Nice. Okay. Okay. Alright, so now we kind of got the basics of just how to write in GDScript, how to write functions, how to deal with variables, using the lists and arrays, and obviously as we get into it, it's gonna get a lot bigger. So I did start with nodes and scenes, I think in the first one. I'm sorry, I'm trying to close all these tabs right here where I was looking into these. Okay. Alright. So, interesting. You know what? I think the first thing this upcoming video, I think I'm gonna just like work on documentation, but with the documentation, I think I'm gonna start, I wanna do something. As I'm looking at the documentation, I want to have a side-by-side with just playing around and sandboxing. And I think what I want to sandbox is a menu screen. Maybe we'll start with like the skeleton design of just how I want a menu screen to look like. And like making sure the working with buttons, working with whatever I can, and then like, writing the code for that, how buttons work, learning about like maybe the on clicks or the listeners. Yeah, okay. I think that would be a good start, is just let's figure out how to code up a menu screen, a skeletal design, and then that will help me kind of play the part in UI design, and possibly I did watch some other YouTube videos like people using Figma. I'm kind of interested in that, and I have a sprite for my pixel art, so that would be a great segue into learning pixel art. So yeah, okay, we'll figure that out. My first mini project, I guess, or sandboxing project, will be just to make a menu screen, and make sure that the buttons actually work. Cool. Well, thank you so much for following along with the GDScript from zero, and thank you so much to Godot documentation and the Godot developers even creating that free course. Again, you can totally do it yourself as well. It is in the introduction tab, I believe. And just be able to explore and sandbox on your own, or but yeah, thank you so much for following along. Hope y'all have a great rest of your day, and take care. Bye.